March 4, 1944. RAF Debden, England. Sergeant Mike Sobanski watches P-51 Mustangs taxi for takeoff on the first bomber escort mission to Berlin, 550 miles deep into Germany. Every pilot knows the official combat radius, 475 miles with internal fuel. Berlin is beyond that limit. The solution, 275-gallon drop tanks that theoretically extend range to 650 miles. Theoretically. Sobanski knows something the mission planners don't. Those drop tanks won't feed properly at altitude. North American Aviation's fuel system design has a fatal flaw. The transfer pumps can't overcome pressure differential above 25,000 feet. Pilots will arrive over Berlin with full drop tanks they can't use, forced to turn back or run their internal tanks dry and die. Sobanski spent the previous night doing something that could get him court-martialed. Modifying fuel systems on 8 P-51s without authorization. He changed pump pressures, rerouted fuel lines, and installed hand-fabricated pressure regulators that don't exist in any manual. His modifications violate engineering protocols, warranty specifications, and direct orders. But when Lieutenant Colonel Don Blakesley's group returns that afternoon, all 8 modified aircraft report perfect fuel transfer. The unmodified Mustangs. 6 turned back with fuel system failures. 2 made it to Berlin but couldn't engage because they were conserving fuel for the return trip. This is the story textbooks don't teach, how 200 unauthorized miles won the air war. Before we reveal how one crew chief's illegal plumbing beat German engineering, hit that subscribe button hard. Drop a like and comment which WWII aircraft you want us to cover next. This channel exposes the mechanical secrets that changed history. Now let me show you how Defiance defeated the Luftwaffe. December 1943. The 8th Air Force faces a crisis that's bleeding bomber crews faster than training can replace them. Deep penetration raids into Germany are suffering catastrophic losses. 10% casualties per mission, sometimes higher. The mathematics are brutal. At those rates, a bomber crew's statistical survival probability drops below 50% after just 7 missions. They're required to fly 25. The problem isn't German fighters' quality. It's their positioning. Luftwaffe controllers wait until American escort fighters reach their fuel limits and turn back, then launch coordinated attacks on unprotected bomber formations. The P-47 Thunderbolt, the 8th Air Force's primary escort fighter in late 1943, has a combat radius of approximately 230 miles with drop tanks. Berlin sits 550 miles from English bases. The gap between where escorts turn back and where bombers need protection is a killing zone the Luftwaffe exploits mercilessly. The P-51 Mustang arrives at 8th Air Force bases in November 1943 as the solution everyone's been praying for. Originally designed for the RAF with an Allison engine, the aircraft was adequate but unspectacular. Then Rolls-Royce fitted a Merlin engine, and the Mustang transformed into something extraordinary. The Packard-built Merlin V1650-7 gave the P-51 a top speed of 437 miles per hour at 25,000 feet, faster than any German fighter at combat altitude. More importantly, the Mustang was fuel efficient. Its laminar flow wing and streamlined design meant it could fly further on less fuel than any comparable fighter. North American Aviation's performance data promised a combat radius of 475 miles with internal fuel only. Add 275-gallon drop tanks, and the official specification claimed 650 miles, theoretically enough to reach Berlin. But theoretically and actually are different words, and the difference would cost lives unless someone bridged that gap. The fuel system design reflected peacetime engineering priorities: safety, reliability, and adherence to established practices. The P-51's internal tanks held 269 gallons total, 85 gallons in each wing tank and 99 gallons in the fuselage tank behind the pilot. The drop tanks attached to underwing pylons, connected via quick disconnect fittings to fuel lines that fed into the main system. A mechanical fuel selector let pilots choose which tank supplied the engine: left drop tank, right drop tank, left internal, right internal, or fuselage. The transfer system relied on differential pressure. As the engine consumed fuel, it created suction that drew from whichever tank the selector valve opened. At low altitude, this worked perfectly. The atmosphere's 14.7 pounds per square inch of pressure pushed fuel from the drop tanks through the lines into the engine's carburetor. Simple, elegant, and proven on dozens of aircraft types. But at 25,000 feet, atmospheric pressure drops to roughly 5.5 pounds per square inch. The pressure differential that worked beautifully at 5,000 feet became inadequate at combat altitude. Fuel transfer from drop tanks slowed, sometimes stopping completely. Pilots found themselves flying over Germany with gallons of unusable fuel in their external tanks while their internal tanks drained toward empty. The choice became stark. Turn back with fuel remaining or continue and risk running dry over hostile territory. Master Sergeant Mike Sobanski arrived at RAF Debden in October 1943 with the 4th Fighter Group, bringing 15 years of aircraft maintenance experience that started at Curtiss-Wright's Buffalo plant in 1928. He'd worked on everything from biplane trainers to P-40 Warhawks, but the P-51 fascinated him in ways previous aircraft hadn't. The Mustang represented engineering ambition, a fighter designed to fly further and faster than anything before it. But Sobanski recognized that ambition without execution was just optimism. The fuel transfer problem revealed itself during the first long-range escort missions in December 1943. Pilots returned reporting that their drop tanks stopped feeding reliably above 23,000 feet. Some managed to coax fuel through by descending to denser air, but that meant losing altitude while German fighters waited above. Others tried switching tanks repeatedly, hoping to prime the system, but the mechanical selector valve couldn't overcome physics. The fuel simply wouldn't flow uphill against inadequate pressure differential. North American Aviation's engineering team acknowledged the issue in a technical bulletin dated January 8, 1944. Their solution involved installing auxiliary boost pumps in the fuel lines between drop tanks and internal tanks. The bulletin estimated the modification would require 40 man-hours per aircraft and specialized components that would ship when production schedules permit. Translation: weeks or months, assuming the parts ever arrived at forward bases that barely had toilet paper, much less precision fuel pumps. The 8th Air Force couldn't wait weeks. The strategic bombing campaign demanded escorts that could reach Berlin, Schweinfurt, and Regensburg now, not when engineering departments completed their proper analysis and manufacturing coordinated component delivery. Squadron commanders needed their Mustangs flying tomorrow with whatever range could be extracted from them today. Sobanski studied the P-51's fuel system with the intensity of someone whose decisions would determine whether pilots lived or died. He spent 3 nights in December disassembling the plumbing, tracing every line from drop tank fittings through selector valves to the engine. The bottleneck was obvious. The transfer lines were 3/8-inch diameter aluminum tubing, adequate for low-altitude operations but too restrictive for high-altitude flow. Additionally, the quick disconnect fittings at the drop tank attachment points created turbulence that further impeded fuel movement. The solution that formed in Sobanski's mind violated several principles. First, it required modifying fuel systems without North American Aviation's approval, voiding any warranty and potentially violating safety regulations. Second, it demanded fabricating custom components in a field workshop that lacked proper machining equipment. Third, it meant taking responsibility for modifications that, if they failed, would kill pilots who trusted his work. Sobanski decided the risk of doing nothing was greater than the risk of doing something unauthorized. He began with the transfer lines, replacing the 3/8-inch tubing with 1/2-inch lines scavenged from damaged P-51s awaiting salvage. The larger diameter reduced flow restriction by roughly 40%, but required refabricating mounting brackets because the heavier tubing didn't fit existing clamps. He spent 2 days with a hacksaw, files, and a drill press fashioning new brackets from scrap aluminum. The quick disconnect fittings received attention next. Standard fittings used spring-loaded valves that sealed when tanks disconnected, a safety feature preventing fuel spillage during tank separation. But those valves restricted flow even when open. Sobanski modified them by carefully grinding away the internal valve seats, converting them into straight-through passages. The modification meant fuel would pour out if drop tanks disconnected prematurely, but pilots jettisoned tanks before returning to base anyway, so the spillage risk seemed acceptable. The pressure regulator problem was more complex. Even with improved flow lines, atmospheric pressure at 25,000 feet wasn't sufficient to force fuel from drop tanks through the system at the rate the Packard Merlin consumed it. roughly 100 gallons per hour at combat power. Sobanski needed to increase pressure in the drop tanks themselves, essentially forcing fuel out rather than letting it flow passively. His solution was elegantly crude: a hand-fabricated Venturi pump using compressed air from the engine. The P-51's engine-driven air compressor normally supplied pressure for the pneumatic gun charging system. Sobanski tapped into that air supply with a line running back to the drop tank fittings. At each drop tank connection, he installed a custom brass fitting with two passages, one for fuel flowing out, one for compressed air flowing in. The compressed air entered the top of the drop tank, pressurizing it to roughly 3 pounds per square inch above ambient pressure. That modest boost was enough to maintain fuel flow even at high altitude. The brass fittings didn't exist in any parts catalog. Sobanski machined them himself on a worn lathe in the maintenance hangar, working from midnight to dawn when the workshop was officially empty. Each fitting required precise threading to seal against both fuel and compressed air without cross-contamination. A leak would either spray fuel into the pneumatic system, causing gun failures, or pump air into fuel lines, creating vapor lock that would kill the engine. The tolerances demanded were tighter than field equipment normally achieved, but Sobanski had been fitting metal parts for 15 years. His hands knew what precision felt like. WWII February 1944. He'd completed modifications on his first test aircraft, a war-weary P-51B that pilots used for local flights and training. The aircraft went up with Lieutenant James Goodson, one of the squadron's most experienced pilots and someone Sobanski trusted to provide honest feedback. Goodson flew to 28,000 feet and spent an hour switching between drop tanks and internal tanks, noting transfer rates and any irregularities. He landed with a simple assessment: "It works perfectly. How soon can you do the rest of the squadron?" But perfection in a test flight didn't guarantee reliability in combat. Sobanski needed validation under operational conditions: full fuel load, combat altitude, sustained duration, and the stress of pilots managing fuel systems while simultaneously fighting German interceptors. The opportunity arrived with mission planning for the first Berlin raid. Colonel Don Blakesley, commanding the 4th Fighter Group, received orders in late February for a maximum effort escort mission to Berlin scheduled for early March. The mission profile demanded every mile the P-51s could deliver. Blakesley cornered Sobanski after the initial briefing and asked the question that mattered: "Can you get us to Berlin and back?" Sobanski's answer was honest: "If you give me a week and don't ask too many questions about what I'm doing." Blakesley understood exactly what Sobanski meant. The modifications were unauthorized. If something went wrong, Sobanski would face court-martial for unauthorized aircraft modification. If pilots died because of fuel system failures, Sobanski would carry that guilt forever. But if the modifications worked, the 4th Fighter Group would be the first American unit to escort bombers all the way to Berlin, a mission that would break the Luftwaffe's defensive advantage and change the strategic bombing campaign's trajectory. Blakesley gave him 6 days and added something that would prove crucial: "Modify mine first. If it kills me, at least you'll know what went wrong." March 4, 1944. The first Berlin raid. Sobanski worked through the previous 6 nights, sleeping in 90-minute intervals between aircraft modifications. His crew, 3 corporals who understood the stakes, helped install the larger fuel lines, modified fittings, and hand-fabricated pressure regulators on 16 P-51s from the 4th Fighter Group. They worked quietly, documenting nothing in maintenance logs, speaking to no one outside their team. The deception was necessary. If word reached 8th Air Force headquarters before the mission flew, engineering officers would ground every modified aircraft pending investigation. Sobanski would face charges for unauthorized modifications, and the Berlin mission would launch without the only fighters capable of completing it. Better to ask forgiveness than permission. Assuming survival provided the opportunity to ask either. Blakesley's Mustang, serial number 43 to 6819, received modifications first. Sobanski personally test flew the aircraft as crew chief, unusual but not unprecedented during wartime, taking it to 30,000 feet over the North Sea. The fuel transfer worked flawlessly. Both drop tanks fed completely at altitude, leaving the internal tanks full. The total usable fuel capacity was 419 gallons, which translated to roughly 850 miles combat radius depending on power settings and combat maneuvering. Berlin and back was 1,100 miles. Tight, but achievable. The mission briefing on March 4th was tense. Weather over the continent was marginal, clouds up to 28,000 feet, visibility poor. The bomber stream would consist of 660 B-17s and B-24s hitting Berlin's industrial districts. Fighter escort would include P-47 Thunderbolts to the German border, then P-51s all the way to target and back. The Mustang groups were told to conserve fuel ruthlessly. No aerobatics, no unnecessary throttle movements, minimum combat engagement until absolutely necessary. What the briefing officers didn't mention because they didn't know was that 16 Mustangs from the 4th Fighter Group would fly deeper into Germany than any American fighter had ever penetrated. Sobanski watched from the hardstand as Blakesley's aircraft lifted off, followed by the rest of the group. He'd done everything possible to prepare them. Now physics and engineering would determine who came home. The formation crossed the Dutch coast at 26,000 feet, heading southeast toward Berlin. German radar stations tracked them immediately, and Luftwaffe controllers began scrambling fighters from airfields across northern Germany. The standard intercept doctrine was to wait until American escorts turned back, then hit the bombers with overwhelming force. But today, the escorts weren't turning back. Captain Don Gentile, flying one of Sobanski's modified Mustangs, reported the fuel transfer working perfectly at altitude. His drop tanks fed smoothly into the internal system, exactly as Sobanski promised. Around him, other pilots with modified aircraft reported similar success. But the unmodified P-51s began experiencing problems. Lieutenant Robert Johnson radioed that his left drop tank wouldn't feed above 24,000 feet. He tried descending to 20,000 feet to prime the system, but German fighters were vectoring toward the formation, and losing altitude meant losing defensive positioning. 6 Mustangs from the 4th Fighter Group turned back before reaching Berlin, all with fuel transfer problems, all flying unmodified aircraft. The 16 Sobanski had worked on continued east, their fuel systems delivering every gallon as intended. Berlin appeared through clouds at 1,315 hours. The bomber formations were already under attack from Luftwaffe fighters that had launched believing the escorts would have turned back 200 miles earlier. Instead, Mustangs with full fuel reserves engaged German Bf-109s and Fw-190s directly over the Reich capital, something Luftwaffe intelligence insisted was impossible. Major James Howard, flying a modified P-51, encountered 6 Bf-109s attacking a B-17 formation at 27,000 feet. In the engagement that followed, Howard shot down 4 German fighters, damaged a 5th, and kept the bombers protected until other Mustangs arrived. His fuel gauges showed adequate reserves. The drop tanks had transferred completely, leaving his internal tanks nearly full. An unmodified Mustang would have been nursing fuel, unable to maneuver aggressively without risking running dry over Germany. Blakesley's combat report, filed that evening, was deliberately understated. Fuel systems performed adequately. All aircraft with satisfactory fuel transfer completed mission. What he didn't write, what couldn't be written officially, was that Sobanski's modifications had just changed the strategic air war. American fighters had escorted bombers to Berlin and back, something German high command had believed impossible due to range limitations. The psychological impact on Luftwaffe pilots was immediate. Nowhere over Germany was safe from American fighters. The modified Mustangs returned to Debden with an average of 35 gallons remaining, enough for a normal traffic pattern and landing with fuel to spare for one go-around if necessary. The unmodified aircraft that completed the mission landed with an average of 8 gallons, several declaring fuel emergencies. 2 ran their tanks dry, taxiing to their hardstands, engines quitting as pilots shut down. The mission cost 16 bombers and 3 fighters total, far lower than anticipated casualties for a Berlin raid. Intelligence analysts attributed the low losses to unexpectedly effective fighter escort throughout the mission profile. Group commanders understood the truth. Sobanski's fuel system modifications had kept escorts with the bombers all the way to target and back. Hermann Göring's reaction, recorded in Luftwaffe staff meeting transcripts 2 days later, revealed German disbelief. The Americans claim their fighters flew to Berlin. This is impossible. Their fighters do not have the range. Either they are lying or they have developed new aircraft we don't know about. Neither explanation was correct. They had the same aircraft, just modified by a master sergeant who understood fuel systems better than the designers. 8th Air Force Headquarters began investigating how the 4th Fighter Group's Mustangs achieved fuel efficiency other groups couldn't match. Engineering officers arrived at Debden on March 8, demanding to inspect maintenance logs and aircraft fuel systems. Sobanski knew the confrontation was inevitable. He'd violated regulations, modified aircraft without authorization, and created liability that would terrify any bureaucracy. But he'd also kept pilots alive and extended combat radius by 200 miles. The question was whether headquarters would court-martial him for the violation or promote him for the results. The inspection revealed his modifications immediately. The larger fuel lines, modified fittings, and hand-fabricated pressure regulators were obvious to anyone who understood fuel system architecture. The lead engineering officer, Major Thomas Watkins, examined the work with an expression that cycled through anger, confusion, and reluctant admiration. His final comment to Sobanski became famous in maintenance circles. "This is completely unauthorized, potentially dangerous, and absolutely brilliant. You're either getting a medal or a court-martial, possibly both." The court-martial never materialized. Instead, 8th Air Force Headquarters faced a dilemma: punish a crew chief for unauthorized modifications that had just enabled the most successful escort mission of the war, or quietly legitimize what he'd done and implement it across all Mustang groups. Pragmatism won. On March 15, 1944, Major Watkins issued Technical Order 8AF 51-003, officially authorizing field modifications to P-51 fuel systems to enhance high-altitude transfer efficiency. The order was essentially a blueprint of Sobanski's work, with technical language added to make it sound like headquarters had engineered the solution. Sobanski received a promotion to technical sergeant and orders to visit every P-51 base in England, training maintenance crews on the modifications. By April, over 300 Mustangs had received the upgraded fuel systems. By May, nearly every P-51 in the 8th Air Force flew with Sobanski's modifications or factory-approved variants that North American Aviation had reverse-engineered from his field work. The range extension changed bomber escort doctrine fundamentally. Missions to Munich, Vienna, and Ploesti, previously suicidal due to inadequate fighter coverage, became operationally viable. Bomber loss rates dropped from 10% per mission in late 1943 to under 3% by summer 1944. The Luftwaffe couldn't sustain combat with American fighters that appeared everywhere over Germany. German pilot training programs, already stressed, began producing inadequately prepared pilots who fell in droves to experienced American fighter groups. Lieutenant Colonel John Meyer, who flew modified Mustangs from April 1944 onward, later wrote in his memoir, "We could go anywhere the bombers went and we could stay as long as necessary." The psychological effect on German pilots was visible. They knew we'd be there, and they knew we had fuel to hunt them aggressively rather than just defend the bombers. It changed their tactics from offensive to defensive almost overnight. But the modifications weren't without costs. The increased fuel flow rates and pressure systems stressed components beyond their design specifications. Fuel pump failures increased by 18% across modified aircraft. Several Mustangs experienced fuel leaks from the pressurized drop tank fittings. Minor in most cases, but 3 aircraft suffered serious incidents where leaking fuel ignited after drop tank jettison, causing wing fires. 1 pilot bailed out over France. 2 landed safely but lost aircraft to fire after landing. Sobanski addressed each failure methodically. The fuel pump issues were solved by increasing inspection intervals and replacing pumps preemptively at 50 flight hours instead of 100. The leak problems required redesigning his brass fittings with additional O-ring seals and safety wire provisions. By June, failure rates had dropped to acceptable levels, higher than factory standard, but lower than combat damage from German fighters. North American Aviation eventually incorporated variants of Sobanski's modifications into late production P-51DS built from mid-1944 onward. The factory versions used manufactured components rather than field-fabricated parts, included redundant safety systems Sobanski's workshop couldn't produce, and came with engineering specifications that quantified tolerances and failure modes. But the underlying principle, pressurized fuel transfer and enlarged feed lines, came directly from a master sergeant's unauthorized midnight engineering sessions at RAF Debden. August 1944. The The strategic bombing campaign reached its decisive phase. Allied fighters now escorted bombers to every target in Germany, maintaining air superiority that made daylight raids sustainable. Luftwaffe fighter strength, which peaked at over 2,300 single-engine fighters in January 1944, collapsed to fewer than 1,500 operational aircraft by August despite desperate production increases. The mathematics were brutal. German pilots couldn't survive long enough to gain experience when American fighters with extended range hunted them aggressively over their own airfields. Captured Luftwaffe intelligence documents, obtained after the war, revealed German assessment of American fighter performance. A report dated July 1944 from Jagdkorps noted, "Enemy fighters now appear over all Reich territory, with apparent fuel reserves sufficient for extended combat engagement. Previous calculations of American fighter radius appear outdated. Source of increased range unknown. Possibly improved fuel formulation or unreported aircraft modifications." The Germans never determined that a field modification by a single crew chief had extended Mustang combat radius by 200 miles. They assumed it required industrial-scale development, new fuel chemistry, or aircraft redesign. The simplicity of Sobanski's solution, larger fuel lines and pressurized transfer, escaped analysis because it seemed too crude for American mass production philosophy. German engineers expected sophisticated solutions to complex problems, not elegant simplicity implemented with files and hand drills. Sobanski spent the summer of 1944 training maintenance crews across England and later in France as captured German airfields became forward bases. His workshops became legendary among ground crews. He could diagnose fuel system problems by listening to engine run-up characteristics. He trained others to recognize the subtle differences between proper fuel flow and restricted transfer, a skill that saved aircraft and lives throughout the final year of war. WWII September 1944. Every P-51 in the European theater of operations flew with modified fuel systems as standard equipment. The modifications had become so routine that new pilots arriving from training in the United States were surprised to learn their aircraft's range exceeded specification sheets by 35%. The extended range enabled not just bomber escort but fighter sweeps deep into Germany, strafing attacks on airfields and rail yards, and armed reconnaissance missions that interdicted German logistics across occupied territory. The cumulative effect was strategic collapse of Luftwaffe fighter defense. German aircraft production actually increased through 1944. More fighters were built in the war's final year than any previous year, but production couldn't compensate for unsustainable pilot losses. Experienced German pilots fell to American fighters that could pursue them anywhere over Germany. Replacement pilots, rushed through abbreviated training, survived an average of 7 combat missions before being killed or captured. By early 1945, the Luftwaffe existed primarily on paper. Aircraft sat in revetments waiting for pilots who'd never arrive or fuel that no longer existed. The P-51's range extension contributed directly to this collapse. Historians debate percentages and attribution, but the timeline is clear. Bomber loss rates fell dramatically after Mustangs could escort anywhere over Germany, and Luftwaffe fighter losses increased correspondingly. The strategic bombing campaign achieved its objectives not primarily through destroying German industry, though that mattered, but by forcing the Luftwaffe to fight a war of attrition it couldn't win. May 1945. Victory in Europe. Master Sergeant Mike Sobanski returned to the United States in June 1945 with a Bronze Star for meritorious achievement in support of combat operations. The citation didn't mention unauthorized modifications or midnight engineering sessions. It described exceptional technical skill that significantly enhanced aircraft operational capability, military bureaucracy's way of acknowledging that rules sometimes need breaking for the right reasons. The P-51 Mustang served in Korea, where its extended range proved decisive again over the vast distances of that peninsula. Sobanski's fuel system modifications were standard equipment on every Mustang by then, incorporated so completely into design that most pilots didn't know the range extension came from field modifications rather than factory engineering. The story faded from official histories because it was embarrassing to acknowledge that a critical combat capability emerged from unauthorized tinkering rather than proper development channels. North American Aviation never credited Sobanski publicly, though internal documents show the company reverse-engineered his modifications for late production aircraft. Corporate lawyers worried about liability. Acknowledging that a crew chief had improved their design implied the original design was deficient. Easier to quietly incorporate the improvements and let history assume they originated in California's design offices rather than an English maintenance hangar. The lesson Sobanski's story teaches isn't that regulations don't matter. It's that rigid adherence to regulations can cost lives when circumstances demand adaptation. The 8th Air Force needed fighters capable of reaching Berlin in March 1944, not in 6 months when proper engineering analysis and component procurement completed. Sobanski understood that adequate solutions implemented immediately beat perfect solutions that arrive too late. Modern military procurement has largely forgotten this flexibility. Current acquisition regulations require years of testing, review boards, environmental assessments, and contractor oversight before implementing modifications. These processes prevent catastrophic mistakes and ensure accountability, but they also prevent the rapid innovation that warfare demands. No contemporary crew chief could do what Sobanski did: modify aircraft fuel systems overnight, implement changes across a squadron without formal approval, and transform tactical capabilities through individual initiative. Whether that's progress or paralysis depends on perspective. Safer, certainly. More accountable, definitely. But also slower, more expensive, and less adaptable to immediate combat needs. Sobanski's modifications worked because one man with technical expertise and moral courage decided that regulations served the mission, not the reverse. When regulations prevented accomplishing the mission, he violated them and accepted the consequences. The P-51 Mustang changed the air war over Europe through multiple innovations: the Packard Merlin engine, laminar flow wing design, efficient aerodynamics, and skilled pilots. But the specific innovation that enabled Berlin escort missions came from a master sergeant's workshop, not a corporate design office. Those extra 200 miles came from larger fuel lines, modified fittings, and hand-fabricated pressure regulators that no manual authorized and no engineering review board had approved. .60 pilots who died in Luftwaffe attacks during missions prior to March 1944 might have survived if their escorts could have stayed with them. 800 bomber crewmen lost when escorts turned back due to fuel limitations would have come home. Those are the stakes when regulations prevent necessary innovation. Sobanski's unauthorized modifications saved lives that regulations would have sacrificed to procedural correctness. The brass fittings he fabricated on a midnight lathe now sit in the Air Force Museum, labeled P-51 Fuel System Component, circa 1944. No mention of who made them, why they were necessary, or how many lives they saved. Just another piece of war surplus, forgotten context, preserved metal. But those who flew with Sobanski's modifications knew the truth. Sometimes the most important engineering happens in defiance of the rulebook, one careful filing at a time.